Welcome back to Introduction to Programming. This is video 20 in our series. My name is John Duane. In the last video we began our coverage of text file input-output. Today we will continue by walking through an example that reads a comma delimited file and writes out a fixed column width file. First, a little review. Remember from the last video I mentioned file handles. Well, let's go over that again. This is important. I've got a little picture here. So file handles. This is part of the Visual Basic language that has not changed since the early 1980s, when there were no high-level functions for dealing with files. So when working with text files in Visual Basic, the operating system has to have an integer associated with every file that is open. This is called the file handle. And you can see that in my diagram here, where we have the input file has a file handle of 1, the output file has a file handle of 2, and any data that's interchanged will probably sit in a buffer of some kind. Now every statement that you write that operates on a text file will need to include this file handle. It seems needlessly repetitive, especially if you're only working on one file, but it does give you the flexibility to work on multiple files at the same time, so that's very handy. For instance, let's say you're reading through the lines of a text file. We'll call this file number 1, kind of like in our diagram here. You want to log an entry into another file every time you encounter an exception. Let's call the log file file number 2. In this situation, both files are open at the same time, so you are reading data off file handle 1 and writing data to file handle 2. This is way more efficient than saving all the exceptions to an array and then writing the array to a file later. Okay, so now about our example. Now this focuses on the census file that we saw in a previous video. So some things for you to think about while I walk through the code. The statements to open and close files do not differ based on the file format, comma delimited or fixed column width. However, the statements to read the data and move the contents to memory, we call them buffers sometimes, those statements are different. So today we'll see how this works for comma delimited files, and in the next video we'll see the approach needed for fixed column width files. So keep an eye on that. The other thing to focus on is the way the example deals with the population number. It has to translate it from a string to a double in order to get rid of the commas. That way you could actually do some math on the number. Then, in order to get the number to print properly in the new file, the program converts it back to a string and write justifies it. So that'll be an interesting part of this program. So now we're going to walk through the code. So the interactive development environment is on the screen, and we'll just start from the top. So we call this convert comma delimited file. That's the name of the program. We start off by declaring a file system object, FSO. Then we've got a string variable that'll hold the file name. We have 3 variables that'll help us with file handling. Note that one of them is called int file as an integer, so that'll be our file handle. We've got a variable here, I'm calling it string temp state. This will help us store the name of the state when we're doing the output. You'll see how that works later. This is interesting. This is a fixed length string variable. We haven't done this in any examples before, and this is how you would establish the fixed length of 11 characters. So star and then the number. So here I want it to be 11 characters long. This will be a variable that will hold the population after we convert it to a number. So this is data type double. Here's our array where all the data will go. We'll call it array census, and it's going to be variant because it'll have a mixture of data types in it. Here's the file name for the input file. So it's fully qualified, has to have the drive, all the folders, the complete path all the way to the file name with the extension. And this is a CSV file, and as you'll notice, there it is. Look at this thing. So comma delimited fields. There are 23 columns going across. Trust me when I tell you, I had to count these, and there are 23 fields, including the state. And the first row are column headings, so that'll be important to keep in mind later. So that's our array, that's the file. Here's code that should look familiar. We've done this in previous videos where we will check for file existence using the file system object. If the file is found, and hopefully it will, we will redimension the array to a two-dimensional array with rows and columns. As you saw a minute ago, it's going to have 23 columns, so there's 1 to 23. And then the first expression here is the rows. In the last video we demonstrated this function, lines. I have that down here. Lines, this is the function that opens the file and counts the lines in the file, so we know how many there are. So we use that there. And now here's where the fun begins. This is the procedure to read the file row by row and input all the data from the file into the array. So this array is going to have probably about 52 rows and 23 columns, so fairly good size array. But it starts like this. We'll establish the file handle using the free file function, set our counter I to 0. We will open the file for input. We use input because we're reading the file, and then there's our file handle. So open string file for input as int file. We then have a loop. This is a do until end of file loop, and end of file takes as an argument the file handle. Every time we loop through, we increment the counter by 1. That I variable becomes the row variable, so every time we make a reference to the array, the row will be the variable, but the column will actually state what the number is because we know what that will be. So the way this works is the input term here, this input function, says to the compiler, we're going to read the next field in this row of data and put it into this variable or this container, this buffer, whatever it is. In our case, it's an array element. And then if there is another array element following it with a comma between, then we'll go to the next field and the next field and the next field, and it'll do that 23 times. And then once it hits 23, we'll loop back, and at that point in the file we're on our next row. Here we'll increment the counter, and so now the array row indicator will be a 2, and we'll go through again and again and again. So that's how you read a comma delimited file and insert the data into either variables or array elements. Then at the end we close the file and we're done with that file. So now the next thing we want to do is we want to actually output that data to a fixed column width file, because you've got to admit that's hard to read, but this would be easier to read. So that's what we're going to create. So let's go back to the code and let's kind of walk through this. So here we're getting another file handle, opening our output file. We're calling it census.txt for output now because we're writing a file. There's our file handle. We're going to use a for next loop to loop through all the elements in the array. Well, all the elements except for the first one, because those are column headings. We don't care about them. And the way we do that is by saying for I equals 2 to upper bound ARR census. 2 meaning we'll start at the second element. We'll leave the first element alone. Then the next two statements here, we're assigning the two array elements that we're interested in, 1 and 12. 1 is the name of the state, and 12 is the census for 2010. So we're skipping all the ones in between because we don't care about them. Putting those values into these string variables and using the trim function to take away the white space. So that's terrific. And then here is the expression you would write to the file. So print, £, file handle, comma, and then whatever it is you want to print. So we're going to print those two variables, and then in between I've got this tab function. What this does is this moves the cursor to the 25th column and then prints this next item. So I could string a whole bunch of these along here, you know, tab 40, tab 60, tab 70, and print more and more variables. That's kind of how you would get a wider fixed column width file. But we're only going to do 2 columns in this example. And then we loop, and then when we're done, we'll close the file. So let's try this out and see what we get. Okay, program runs very quickly, so we'll go here. This file, census.txt, has been updated, so it's asking me, do you want to reload? And I do. And there we go. So one of the problems with this is that this number you can't do any math on because it has all these commas. And it's left justified. That's normally not the way we look at numbers. So let's do one thing. Let's get rid of the commas. So down here, string temp pop, let's convert that to a double data type. And the way you do that is with this command, cdouble, and that will convert the string to a double. So let's do that. Go back to the file, reload, and lo and behold, the commas are gone. Still not right justified though. I kind of like to do that. So let's go back, and I've got a code snippet here that will do that for us. Let's take that and we'll put that into our code here. We'll replace all of this. And let's take a look. So this first part for string temp state, that didn't change, but for the population variable, which is of data type double, we do the conversion here separately, and then this is the interesting part here. I'm going to take the double pop population variable, convert it back to a string, and then put it into string temp pop, which you recall from up above is a fixed length string. Here, see, it's got 11 characters. And then using the rset command, I'm going to push the data in that fixed length string over to the right, so that any white space, if there is any, will be sitting to the left. So this is how you get something to right justify. So let's run that and take a look at the output, reload, and there you go, right justified. So very handy set of procedures here. The right set command operating on a fixed length string. Terrific. So let's wrap up. Today we continued our discussion of text file input output. You saw an example of reading in a comma delimited file and writing out a fixed column width file. Next time we will finish our coverage of text file input output with an example of simultaneously reading in a fixed column width file and writing out a comma delimited file, kind of the opposite of what we did today. So that's it for today. I hope this was helpful. Please subscribe to this video series and write comments about anything that was not clear. I monitor the comments and I will definitely respond. So we'll see you next time.